So we've established that the scientific revolution saw lots of changes in the way people thought. We need to see what those changes are. Now there were, a whole lot of changes during the scientific revolution. I don't want to have to outline every single one, so I'm going to focus on sort of three really big ideas, and we'll track how those ideas change other ways of thinking in society. So one big change comes in astronomy. Remember that really since around 100s AD, you have this idea of a geocentric model of the universe. Partly this was outlined by Ptolemy, the Hellenistic astronomer in the 1st century AD. Also, people just sort of thought this was common sense, right? If you look up at the sky, the sun and the planets and the stars tend to look like they're going in a path around the Earth. You don't feel like you're moving, you don't feel like you're spinning around. It sort of fit common sense that, well, yeah, the Earth's in the middle. What Ptolemy did was just provide a model to explain it. But as we move into the 15th century and 16th century, and you have better instruments to measure things, people noticed this model really didn't seem to fit perfectly. Some of the planets moved kind of weird in the sky. If it's a perfect circle, they should just be going, right across the sky. But instead, they're sort of going and then moving back and then going forward. Some people in the Middle Ages recognized this, especially some Arab astronomers. They tried to explain it, saying that, well, maybe the planets spin around this weird axis and they rotate around themselves. And it fit their observations, but they didn't really quite understand it. But then when we get into the late 15th century and early 16th century, you have this Polish priest and astronomer named Nicholas Copernicus. And Copernicus theorized that maybe the movement of the planets and stars could better be explained by putting the sun in the middle of the universe. This is what we call a heliocentric universe. Maybe everything goes around it. He wrote this. It got published. It got published with a commentary that basically said, well, this is a good theory, but it's really just a thinking exercise and probably not real, which is what Copernicus said. And pretty quickly it kind of just sort of died out. People didn't think much of it. But it does get revived later. As people sort of go back and start reading this, a Danish astronomer by the name of Tycho Brahe decided to sort of take this up. And Brahe was sort of vehemently against this whole idea of a heliocentric universe. He made lots of observations and using newer instruments and better measurements, and his goal was to disprove the Copernican theory here. He came up with his own model that said that all the planets go around the sun except the Earth, and the sun goes around the Earth. Brahe died fairly young, but all of his data and all his information went to his student and assistant, a guy named Johann Kepler. Kepler studied this information. He wanted to sort of see, was Brahe right or is Copernicus right? And Kepler took this idea and said, okay, I think Copernicus is right and the planets do go around the sun, but they're not a perfect circle, which is what everyone had assumed because, maybe as the universe is perfect. But instead he figured maybe they go around in these elliptical orbits. Kepler, it turned out, was right. Now the problem Kepler, continued to have is that not everyone accepted this idea. People were pretty tied to the Ptolemaic model, the old geocentric model, and he didn't have all the data necessary. He couldn't explain everything about these movements. But it did continue the debate. And this went further when a Italian astronomer, Galileo Galilei, first used the telescope to observe the planets, and what he saw when he looked at Jupiter was Jupiter had its own moons. Everyone had always assumed that all the satellites, all the things that rotate around other things, were things that just went around the Earth, or in the Copernican theory, went around the sun. Now you have this idea that other planets have their own bodies that rotate around them. And so taking Galileo's observations along with Kepler's theories, you have a shift in the way people think, not only about astronomy, but about the universe. The big idea here is a change. Humanity maybe isn't the physical center of the universe. And if it's not the physical center, you might have, questions about, well, is it really like the philosophical center? Is it, is humanity the center of everything? And if not, how does that have to change our thinking? Another change in science was the development of what we call the scientific method. One thing to note is that the idea that you should make observations and record things wasn't brand new. You saw some of that thinking again back in the Middle Ages. But two thinkers in the 16th and 17th centuries really contribute to develop what we think of as the modern scientific method. One of those was an Englishman by the name of Sir Francis Bacon. Bacon argued that observation alone and referring to classical sources really wasn't enough to back up scientific theories. What you really had to do was make experiments, try things out, see if theories and models fit their reality. And another thinker was a mathematician named René Descartes. One thing to realize is that our modern idea of what science is, which is basically knowledge of the physical universe, was split into lots of different branches. The word science didn't even develop until the 17th century. People called it natural philosophy if they're looking at physics. Or they might call it astronomy, they consider it totally separate if they look at the stars. Math wasn't even considered science. Numbers were seen as just sort of a construct to explain the universe, but not physical reality in itself. Well, Descartes disagreed with that. Descartes said you really need data in numbers to support scientific theories. He developed, for example, the Cartesian plotting. You got a graph, the x and y axis. It's named after Descartes because he came up with it. You combine these ideas together, the idea that you need to experiment and the idea that you need to collect data, and you really have the modern scientific method of testing and theories by experiment and data. And this is going to be a really key idea later when we get to the Enlightenment, but also, of course, a really big idea for science. Some of the biggest changes and most important changes in the scientific revolution came in the realm of physics. The big star of the scientific revolution in physics was the British physicist and mathematician Isaac Newton. Isaac Newton did a lot of things, like invented calculus, for example. But probably the most important thing he ever did was this book that's often just called Principia, The Principles of Natural Philosophy and Mathematics, which basically is arguably the most important science text ever created. What Newton does is he looks at the world and he tries to figure out how can we explain this rationally. And what he comes up with is really a series of formulas that explain sort of how things worked. You want to know, okay, if I push something, how fast is it going to go? He came up with a formula for that. First law of motion. Why do things stop moving after a while? What makes things fall down? People know what gravity was, but he was able to explain it using numbers and formula. And that's a really key idea. This idea that the universe didn't operate just because God made it and he's moving things around, but because it operated by natural laws which people could understand. And that is a really important idea that, again, when we move to the Enlightenment, people are going to look for, well, what is natural law? How does nature sort of exercise its rights here? Which is to say that, what's the best kind of government? Maybe there's a theory that can explain it. How does the economy work? Maybe we can look for a formula to figure it out. How can we be happier? Maybe there's this natural formula or natural law that will explain it for us. And so these ideas together represent a big shift, not only in experimentation and instruments and the scientific realm, but these ideas are also going to be applied to society. And that's going to be what we call the Enlightenment, which we'll talk about in the next video.